This video will help you work with laws of rational exponents and moving these things into radical form. The most important thing to remember is that you're really just dealing with the same laws of exponents that we were dealing with before, first semester. It's just now you're going to have things that are fractions, and then you might have to change these to roots at the end of the problem. So simplify, write answers in simplest radical form. This means when you are all done, you should not have anything with a rational exponent. It should always be moved to a radical. Okay. All right, so first one, 7 to the 1/2 power times 7 to the 2/3 power. Notice you have the same bases. When you have the same bases and you're multiplying, we always add our exponents. So you are just going to do 1/2 plus 2/3. Okay, and you can use a common denominator if you want, or you can just use your calculator. 1/2 plus 2/3 is 7/6. So this is 7 to the 7/6 power. We're going to convert this to a root. Remember, the denominator is your index. But now, remember, if your exponent is larger than your index, that means that we can still simplify. So this 6 means that you need a group of 6 in order for your 7 to come out. Well, we have 7 sevens. So you have 1 that can come out with 1 left over, a remainder of 1. Because 6 goes into 7 one time with 1 remainder. So 1 can come out, 1 stays in. And here's your answer. Okay. All right, let's try the next one. The first thing I'm going to do is, just like before, multiply my exponents. Okay, this is what we used to do first semester when we dealt with laws of exponents. So this will be 27 to the 1/3 times 2 is 2/3. 1/4 times 2 is 2/4, which is 1/2. All right, so 6 to the 1/2. This is just going to become square root of 6. So I'll leave that over here. 27 to the 2/3, this can be broken down more because I know that 3 cubed is 27. So I'm going to rewrite that, and that's to the 2/3 power. The reason that's helpful is because then these 3's are just going to cancel, because remember, you're multiplying. 3 times 2/3 is 6/3, which is just that 2. So you really just have 3 squared. 3 squared is 9. So 9 times root 6 is your answer. All right, same thing for the next one. Let's multiply our exponents. 3 times negative 1/3 is negative 1. 3 times negative 1/3 is still negative 1. And 4 to the negative 1 power is just 1/4. 2 to the negative 1 power is 1/2. Remember, because these negative exponents just mean that the number or variable will move to the denominator. If it's already in the denominator, it will move to the numerator. And then 1/4 times 1/2 is 1/8. Okay, another thing you could do is just multiply the 4 and 2 right now and get 8 to the negative 1 power. You can do that because remember that exponents are just ways of showing roots, and when you have 2 roots, you can multiply those together. So 8 to the negative 1 also comes down to 1/8. All right, next, we have 6 divided by 6 to the 3/4. Now, don't worry about the fact that this is a 3/4. It's the same rules as always. When you're dividing things that have the same base, we always subtract our exponents. So remember, if you had a to the fifth over a squared. 5 minus 2 is a to the third. The larger one was on top, so a to the third will be on top as well. It's the exact same thing. Okay, only you have a fraction. The first 6 has an exponent of 1. The bottom has an exponent of 3/4. 1 is larger, so our answer will appear on the top. 1 minus 3/4 is 1/4. So that's 6 to the 1/4 on the top. Be careful, make sure that it actually looks like an exponent and not 6 and 1/4. Okay, like a mixed number. And remember, you are not done until you don't have a fractional exponent anymore. So this becomes the 4th root of 6. And that 1, remember, is just right here still. Okay, so that's 6 to the 1/4. All right, so we have the cubed root of 162. It doesn't hurt to just check to see if this is a perfect cube. Remember, we can go to our math button, go down to 4, and obviously that's not going to work. So that means we're going to have to break 162 down. I'm going to use a factor tree because that's easiest for me. 2 times 81, 9 times 9, and that's 3 times 3, 3 times 3. So this can be written as 3 to the 4th times 2. And remember, if your exponent is larger than your index, it means that something can come out. So we'll do our exponent divided by our index, 4 divided by 3. That means 1 can come out. And there's 1 left over. This 2 only has an exponent of 1, so it has to stay. 3 times 2 is 6. If you don't want to rewrite it with the exponents, you can also just do a normal factor tree, and remember you need 3 to come out, or a group of 3 in order for 1 to come out. So you have 1, 2, 3, and these guys are left over. So the 2 times 3 is your 6, and your 3 comes out. All right, number 6, the cube root of 25 times the cubed root of 5. So remember, if I gave you root 10 times root 6, you could say that that's root 60, and then break that down. So you can multiply cube roots as well. So the cubed root of 25 times the cubed root of 5 is just the cubed root of 125. And if you type that in, that's actually one you should probably recognize. Hey, you just get 5. That's because 125 is 25 times 5, 5 times 5. So this is the same as the cubed root of 5 to the third. So that cancels, and there's your 5. Or again, you can think of it as you need a group of 3 in order for 1 to come out, and you do have a group of 3. So in any case, 5 is your answer. I hope you're starting to see that there's so many different ways to do each of these problems. So there's not really one way that's better than the other. It's really just going to be your personal preference. And the only way to figure out what you prefer for each type of problem is to just do these over and over and over again. So even though the homework looks really long, you've really got to do all those problems because you'll start forming opinions about what makes the problem easier for you and which way you prefer to do them. All right, this one's super important. I actually don't think these are too bad, but a lot of people don't like them. The tricky thing here is that 10, you can't rewrite that as 5 squared or 2 squared or anything like that. So what you're going to have to do is break it down into a product of primes. So for example, when I say product of primes, I know 10 is the product of 5 and 2. So I'm going to rewrite 10 to the 3/4 as 5 to the 3/4 times 2 to the 3/4. And I'm going to rewrite 6 as a product of primes as well. 6 is 2 times 3. 2 to the 1/6 times 3 to the 1/6. All over 5 to the 1/6, I can't really do anything with that. So there you go. So now this is combining the same rules, exponent rules, that we did in number 4. When you're dividing things with the same base, you subtract your exponents. And number 1, when you multiply things with the same base, you add your exponents. So it's the exact same thing here. We just have a whole bunch at once. So let's deal with the top first. You have these guys right here have the same base, even though I wrote my 2's differently. Okay, same base, and so we are going to add our exponents since they are currently multiplying. So we have 3/4 plus 1/6. And again, you can do a common denominator, or you can just add your fractions together using your calculator. Okay, whichever's fastest for you. All right, so that's 11/12. That means on the top I have a 2 to the 11/12. I also have a 3 to the 1/6, which I'm just going to rewrite because there are no other 3's here, so there you go. Now these 5's, one's in the numerator, one's in the denominator. They're dividing, so we subtract our exponents. 3/4 minus 1/6. Just change this to a minus. That is 7/12. 3/4 is larger than 1/6, so the 7/12 will be in the numerator. All right, now remember, here's the issue. You can't have rational or fractional exponents when you're done. You have to have these as a root. So right now, this would be 2 to the 11th, and it's the 12th root of that. This would be the 6th root of 3, and this would be the 12th root of 5 to the 7th. But we want all of these to be under the same root. Now notice, right, you have a 12th root and a 12th root. That's good. That means these can be together. This one is a 6th root. So we're going to need to change this one to a 12th root in order to combine them all under the same root. So think of it this way. 1/6 needs to become a 12th. What's the same as 1/6? 2/12. So we are just going to rewrite this one as 2/12. And now I can write all of these under one root. Two to the 11th times 3 squared times 5 to the 7th. And this is going to be an absolutely enormous number, so we are just going to leave it with the exponents there. All right, well, that is about all the time we have for our first video. So we did the first side in almost 15 minutes. So stay tuned for part 2 on the back.